Hello, party people. It is Will Pemble. I'm not doing any building this weekend because I gotta go on a trip, but what I wanted to do is share with you a couple of things. First of all, I made a new friend the other day. His name is Ezra, and Ezra's dad is named Matthew. Ezra, it was so cool meeting you and talking to you on the phone a little bit, and I wanted to give you a shout out and say that this video is for you. I also made another friend, a guy named Will from London. Will from London built one of the coolest launch coasters I have ever seen. And so what I did last week was I got on a video call with Will and had him walk me through and talk about how he built this awesome coaster. So that's this week's video, is a recording of the conversation that Will from London and I had about his amazing launch coaster. And I'm talking to as many people as I can, learning as much as I can about building a launch coaster because it's gonna be awesome. So I want it to be incredible. Will from London made a truly incredible thing. There's a link to his video in the comments below, and we'll see if we can cut in some stuff as well. So anyway, that's the deal. Check out this conversation. Will made an amazing thing, man. If I can make something half this cool, it's going to be fully fantastic. And once again, Ezra, great meeting you, man. I really look forward to the next time maybe we get to talk. And if you're ever in California, please let me know because I'd love to meet you. I will talk to you guys soon. Thanks for helping me bring physics, family, and fun to kids everywhere. I'm Will Pemble. Check out this video.
My brother.
Will.
Shaking, dude.
How you doing, man?
Man, it is really, really nice to meet you. I'm trying to get my, so here's the thing, right? It's 8 o'clock in the morning or some godforsaken time of day.
Yeah, hold on, let me just shut these doors. Yeah, it's about 4 p.m. here.
Yeah.
The 9-hour time difference really kills you.
Oh man. Yep. I've got clients in Australia, and so I go to Sydney pretty regularly, like a week out of the month.
Yeah.
And so I'm sort of used to the upside downness of it all.
Yeah.
But it's a little bit. Okay. All right, man. I'm trying to figure out. Okay, gallery view. I want to get my. Are you using a laptop by any crazy chance?
I'm using an iPhone.
An iPhone. Okay, so we can we can get outside if needs be.
Well, did you get my emails?
I did not. Well.
Oh, so thing is that the roller coaster I put up, the deal was I had to use my parents' garden for it, and the deal was that I could keep it up for about 2 weeks, and then they wanted it down. So
okay. Oh my God, that had to kill you.
In a kind of 1 week period of building it, taking it down, the whole lot. And so right now, most of it's in kind of storage, and I've got all the bits. I've got the launch tube here, I've got the valve assembly and everything here.
Okay.
I know what you were thinking. I can see it in my head. You wanted it all laid out and.
Oh, dude, I wanted to ride it. Are you kidding me? I wanted to get out there.
It's a rush. It was so much more than I thought it would be.
Yeah.
Oh
man.
I thought awesome. I knew the numbers. I knew that it would have about 1,000 pounds of thrust.
Yeah.
On it, and I knew that it would be a lot. But I've ridden launch coasters before, and so I know what kind of 2-3 G feels like. Yeah. And this was different. It was so much more violent with the launch because it was just instant.
Yeah, because I saw the video.
Yeah.
We'll do the how do I say your last name? DeBrit?
Yeah, but I don't hide my name, but
we just say Will from London.
Yeah, I don't put it out there.
Okay.
Yeah.
We shot a video last week where we welded together the first piece of track and all of that, and I mentioned you on the thing.
Oh, did you?
You gotta check out Will from London.
I just saw 2 minutes ago that you'd uploaded your second part because I've been refreshing it the past couple of weeks. Has he uploaded it yet?
I know. I have a grown up life, and so I have to do adult things on a pretty regular basis. And Yeah, so I don't get to fart around as much as I wish I could, but
Yeah, but I mean, it's really, really impressive. I mean, what you're planning is, I mean, it's like next level, man.
I just want to do
be...
like a little King to Ka, right? I just want to do like a little whoop, and so.
I mean, is it the whole top hat coming back down?
Yeah,
How
we want to do
the supports for that.
We want the launch, and then the thing
Yeah.
wants to go straight up, and then do kind of a roll as it's going up, roll 90 degrees,
Yeah.
and then over the top, and then roll back the other way 90 degrees and come back.
And is it a full steel track? Like,
yeah.
wow.
Yeah, so the last one we did was like steel with wooden supports, right? The Gold Boss was all wooden supports, so sort of technically a hybrid. But this one we want to do, I'll show you, I just backed my car out of the garage so that I could show you this. And so this is the first, there's like video of it.
Oh, yeah. I see what you're planning.
Yeah, so
That's
I keep
wicked.
it under the, I park on top of it. This is the only piece of track we've got so far.
How long is that piece?
That's 20 feet. So what is that, like?
I can do feet. I learned all my pneumatics. I learned from Americans, so I do everything in metric except height.
Oh, okay.
Which I do entirely in imperial.
Okay, yeah, I'm like, well, I have a friend, Paul Gregg. I'm sure you've heard of Paul Gregg, right? Yeah, that guy. He's so sweet and like a hardcore engineer, like an aerospace, like an actual
His
rocket
videos
scientist.
are crazy. Where he's doing like all the calculations. I'm like, I don't. This is so beyond, like, yeah, it's crazy. Yeah,
he really goes the distance on this thing, because he approaches it from the point of view of somebody who's like building an airplane. And so I was like, oh, well, I think we're going to weld this piece together. And he'll say like, well, you really want to use fasteners for something like that. We never weld things on aircraft because you can't really test a weld really. And so fasteners, he'll go on and on. So anyway, Paul is a gem. He's a treasure.
Yeah, because with the track that I used, I thought you might recognize it, maybe.
It's PVC.
It's PVC.
Well, and it's PVC. I recognize some of the construction technique, right?
Yeah, I thought you might. Yeah.
It was pretty nice. I liked it. It was like good work.
Because I didn't know, because I built mine on like a serious budget. So mine was built for under $300.
Wow.
Yeah. So I had about £250 to work with. I already had an air compressor, so I didn't have to buy that.
Okay.
And I had sort of access to some wood, but not all of it. And I didn't want to use like offcuts and this. I wanted to buy it. And our timber's actually a bit more expensive than it is over in the States.
Mm-hmm.
So and then the other thing was I was seriously limited with size. Like, I knew that corners were totally out. I couldn't do them. I didn't have enough width to do the turning circle. The supports would have been too big. It would have taken too long to make. And so I knew that a linear coaster was possible.
Yeah.
And then, but I started out because I saw your videos and I saw the roller coaster that you made with the chain lift, and I thought, yeah, that would be cool. I could do that, maybe. But it ended up being, I costed it out and I looked at what you have to build, and the chain lifts, man, I mean, you'll know, I mean, they're pretty hardcore when it comes to building those. And the supports needed would have been, you got to build this thing kind of 15, 20 feet tall or whatever to get the speed up. And you end up with quite a big structure. And the whole launch mechanism, it ended up actually being both simpler and cheaper for me to build. And I knew that there's been a couple, like you featured a launch coaster that was done with I think it was bungee cord.
Yeah, that one's in Kentucky. I happened upon that one, and it's at this place in Kentucky where it's called Newton's Attic, and they build all sorts of crazy stuff. And oddly enough, the kid on that coaster is my niece, this little girl. And so I just like
really,
yeah, it was crazy. It was just like I was like, wow, check that out. I was like, oh my god, that's Susan. And so now I'm connected to the Newton's Attic people. The next time I go visit, my mom lives in Kentucky, and so the next time I'm out there, I'm gonna go and like ride this thing. But,
oh yeah, it looks intense. Like the acceleration, it was
yeah.
off.
So like,
yeah,
so here's my question. Okay, keep going. I'm all excited. I got a million questions.
So I had like quite serious limitations, and then I had a time constraint as well. I didn't want to, you know, I'm already not putting out videos as fast as I'd like to. You know, I'd like to be putting them out every month. But I choose quite big projects, and they end up taking quite a while. So I wanted this thing put out in a reasonable time frame. I wanted it so that I could build everything and then have it so I could assemble it and take it down quite quickly.
Mm-hmm.
And then I wanted it so that it wouldn't cost like a huge amount, because I'm a graduate student, you know. And
what do you study, by the way?
I study industrial design.
Okay, nice.
Yeah. But I've been interested in science and technology and maths and engineering for my whole life. I absolutely love it. And so, yeah, so like I choose like a topic each video that I want to focus on. You know, so like this one's like the physicsy one or chemistry one, or yeah. Okay. And so then I had sort of, I had to build this thing. And I started out by just building the launch mechanism. So I bought a piece of 4-inch PVC, and then I bought I made up this kind of valve assembly here. Okay. Where you have an air compressor in here. Yeah. You have this, which is a quick exhaust valve, which is a kind of piston actuated valve. Okay. And then this, which is a kind of solenoid, which actually fires it. And these are kind of weird because they fire by releasing the air behind the piston, and it causes a sort of pressure imbalance.
Okay, now tell me that. Here, wait right there.
Yeah.
I'll be right back. Okay. So I just pulled this out of a.
Hey, you got the same thing. Yeah.
Similar. Well, I think I don't have a piece that you have now. I built this, and this is the reservoir in mine. It's not as big as. This was kind of like a makeshift fireball machine that I was working on, but I think I need the reservoir to be bigger so that I can, you know, have a bigger fireball.
Yeah. So
that fireball is way too big, said no one ever.
Yeah.
Okay, so tell me about now. Go back to that piston valve. What do you got there? Yes.
So this is a so you can build these piston valves, and I think Nighthawk in Light has a great video where he builds quite a large piston valve. Sort of yay big. Yeah. And the idea behind them is that when you have something like a ball valve, when you're dealing with, like, from the pressure's point of view, by the time you crack that ball valve just a little bit, with the thing which he made, which was like an air cannon, the projectile's already come out the barrel by the time you cracked it 10%.
Because it just begins, you get the slow.
So if you slowed the video way down, you would see that, you know, if you had a ball valve, you turn it a little bit, projectile's gone, and all that efficiency is just through the floor.
Right.
So the other option is that you can do something which is called a piston valve, which is this is a kind of pre-bought piston valve. These are about $15. This is a 1/2-inch one. You can get them up to 1 inch or 1.5 inches.
Okay.
And the idea is that this thing won't make a hiss; it will make a crack when it fires. You know, this thing is dumping that air out so fast. And the other thing is I can pilot it by this, which is a 1/4-inch solenoid. It's really small and it's really easy to pilot. So I just had that hooked up to the battery with these, which are 3 switches. So you got the emergency stop, activate, and then fire. And so
that is an awesome switch, dude.
It's good. It's good. Yeah.
Anything with a big red button on it is okay in my book.
It's good. Yeah. I wanted that for the dramatic effect to have.
Oh yeah.
Wow. And so what it allowed for was controllability, because if I used a ball valve, the first thing is you need someone standing behind it to crack the ball valve.
Yeah.
You can use an electronic ball valve, but they open too slowly. And then the other thing is you can use a big version of one of these.
Crazy expensive.
They're just like, this whole thing cost me $20.
Wow. Okay. So how big is your solenoid?
My solenoid's
your solenoid valve. What's
1/4 inch?
That's a 1/4 inch. Okay. So this is a 3/4 inch solenoid. Yeah. And I remember I had to sort of buy it secretly so that Liz didn't see what a 3/4 inch solenoid valve would cost, because they're not trivial.
Yeah, they're expensive.
Yeah.
Yeah. So this allows you to get more than solenoid performance, for very very
piston
cheap.
valve.
Yeah.
And that's
so
a 1 inch. Is that a 1 inch valve?
It's a 1/2 inch valve.
1/2 inch valve. Okay. And that's what powered your coaster. Just a 1/2 inch.
Just a 1/2 inch valve. And the reason why I chose that was, you do like spud guns and you make them and you use sort of larger valves, but the projectile is going.
Yeah, there's easily like 4 air cannon derivatives in this room.
Yeah. So
we made one that made a big ball of. We made one that made like all of these ping pong balls. It's about 5,000 ping pong balls.
Gee.
So we made one.
Wow.
We made one with a big, like I think it was like a 6-inch PVC pipe, and then just like a small solenoid valve, and then it went poof, and it just made like this mushroom.
That's incredible. Wow, that must have been a nightmare to clean up.
Well, you do it for kids, and then the kids are like happy to go and chase around all the colored ping pong balls.
Yeah,
that's just like it's all
amazing.
part of the fun.
That's brilliant. Yeah. So the reason for this is that I chose a half. I could have gone 3/4 or even 1 inch with this valve, but the reason why I didn't was because I actually purposefully wanted it to fill the sort of piston chamber slower.
Okay.
I wanted it so that because I in my head, if I used a big, like a 2-inch, if I built a piston valve made of 2-inch piston valve, it's going to hit you so hard that it might feel uncomfortable. So I wanted it to be so that it would open in a very controlled way where I'd know exactly what it would be like. So it opened the same every time.
Yeah.
So I used this, but then I chose a slightly smaller one so that it would. Oh, sorry. So that it would fill it. So that it would fill the piston housing slightly more slowly.
Yeah.
And so I timed it out, and I timed how long it would take to fire the piston, and it ended up being okay. I probably could have gone slightly bigger, and I would have got more performance.
Yeah.
And the other thing I wanted to do, because I could only buy pipe in the sizes that I have, and really what I wanted to do was to build a 5-meter launch instead of a 3-meter launch.
Okay, so that you could achieve higher speeds, or so that the acceleration could be slower over that distance?
You want the same acceleration, you just want a higher speed.
Thank you.
Yeah. So
good.
you want. I mean,
that's the perfect answer to that question.
Yeah. No, you always want as much acceleration as possible. And like, I was like, the thing was, like, the first time we fired it, and we had we used a phone accelerometer to tell how, and looked at the numbers, and it was peaking slightly over 5G. And I was thinking, no one's going to believe this. No one's going to believe that it's done this.
Yeah.
But it had a drop off. So in the last meter of the launch, it drops off to about 2 or 3. And that's because my accumulator, my air chamber wasn't big enough.
Okay, right. So you just ran out of gas, and we've seen that in a bunch of. I don't know if you're, a MythBusters fan or anything, but one time, they did the Raiders of the Lost Ark ride with the little all of those shooting the darts or just shooting the air, and they ran out of air. And so you always, and that was the problem with my fireball machine and all sorts of things. So yeah, you just run out of air. Did you solve it?
I mean, I could have just built a bigger chamber,
right.
But it would have taken longer to pump up. And
time and money.
And time and money, but it was already. I had a stopper at the end of the track, and it was already hitting that. And so I didn't.
We're gonna end up on top of that shed out there.
I didn't need any more power. Like, it was enough. Like, it was so much. Like, you can forget. Like, have you been to, like, you've ridden launch coasters?
Yeah. I've ridden King to Ka. I've ridden King to Ka. I've ridden Top Thrill Dragster at Cedar Point a couple of years ago. Lyle and I went, and we were there. We got fast passes because we're all really spoiled, and then at the end of the day, we were there on a weekday, so like took Lyle out of school. We're there on a weekday, and at the end of the day, it really, really quiets down before the park closes, and so we just like we rode that thing probably
Yeah.
20 times in an
Yeah.
hour, and it just like, it was awesome. It's like the greatest coaster in the world.
Because I've been wanting to do this since I was about 10 years old, and I never had the means to do it or the money. But we have a theme park in the UK called Thorpe Park, which is nothing like Cedar Point. You know, it's much more, you know, smaller scale.
There is nothing like Cedar Point.
No, but
it's the only one.
We have a launch coaster there called Stealth, and it's like a mini Kingda car. It's 205 feet tall, but it's the same type of deal, right?
Okay.
And it does 0 to 80 in 1.8 or something.
Okay.
And
it's a and probably, is it an Intamin coaster? Do you know by any chance? Okay.
Yeah, it's an Intamin accelerator. Yeah.
Yeah.
So it's cable launch, nitrogen drum, the whole lot. Yeah. And
God bless those guys.
Yeah. I'd never been I'd been in a fast car, and so I'd felt like, like that was a lot of acceleration.
Yeah.
And then I got in this, and I rode this crazy ride, and it didn't feel like acceleration. It felt like something else. It was like, it felt too fast. Yeah.
Yeah, exactly. So I drive a Tesla, and I've been giving people Tesla rides, you know, the all that.
Yeah,
There's a bookend to that coaster down in Southern California at Knott's Berry Farm called Accelerator, and it's an Intamin. It's the 0 to 85. Yeah, well, it was
the first one, right? Was that the first one?
The first.
It was like the first Intamin.
Might have been the first Intamin launch coaster. I mean, they've had some adventures with it, but I've been there. I've been in that room with the 10,000 horse hydraulic motor and all. You know, they let me behind the scenes to.
You're lucky. That's
a really cool room, dude. That's
incredible.
But I was down there a couple of weeks ago after months and months of giving people the Tesla ride, you know, whoa, that's fantastic. And I got on that thing just, you know, I was like, I'm going to ride this. This is probably just about like my car. No, sir. It's like that extra, you know, that 1 second faster. Yeah. it really makes a difference. It's like, awesome.
Yeah. So the ride, to Stealth, which I was riding, 0 to 80 in 1.8, it pulls about 2.5 G, and I was pulling 4 to 5.
Dude, in your video, you can see your face peel back. It's like
and the sound as well. Like, none of the sound was added. Like, I have a sound recorder, and I just bolted it to the thing along with my camera, and then like I heard the raw audio of it, and I was like, this is amazing. Like, it makes it look how it feels, which is like scary fast.
It's
and
absolutely,
you know,
insane.
It's homemade as well, so there's that like when you get on a professional roller coaster, you're like, oh, it will be fine. It's gone through testing. It's all steel. Like, when you ride one that's made out of PVC and wood.
Yeah, tell me about it. I mean, I have because you know, I've built them, I've tested them, I've done the math. It all makes perfect sense in my head, and then there has never, like the Gold Boss coaster, that long, it's 45 feet of lift hill, and you're going tick it, and it goes really slow.
45 feet?
45 feet of lift hill. It's like the thing goes up that high. It gets like 20 feet above. There's like a 20-foot delta from the top to the bottom of the course. But the lift hill is long. I mean, it's just like really, really, and it's like, you know, 40 degrees. It's not trivial. But I've never ridden up that track. I've never ridden up that hill without thinking, this is just a terrible idea. I should not. I should not be on this thing. It's like, and I'm the one who built it, right? I'll put friends on it all day, every day. It's like, sure, go. It's awesome. But like when I get on the thing, I'm like, I am out of my depth.
Because we tested it with. So I done the math, and I said, okay, like we have 100 psi going in the tank, 4-inch piston. Do the whole calculation. It's about 12 square inches. So it's about 1,200 pounds pushing this way.
That's,
you know,
ridiculous.
Yeah. And then I weigh about, you know, with the car, it's about 100 kilos. So about 180 pounds, something like that.
Yeah.
So like you do just like the basic like math, and you work out, okay, like this, like when you do the back of the envelope, it comes out at about 5.5 G. And I said, okay, like that's theoretical. Like, it's probably going
Yeah.
to pull about 2 or 3.
Yeah.
But then we fired it with sandbags, and we were like, oh wait, no, this thing pushes, and it pushes hard. You know, and so you can see on my face when I'm first getting on it, like, I'm terrified.
Yeah. Oh yeah, no, I could see it like in the video, and I don't know, was the video the first ride? Was that like the first? Was that like did you like capture the very first thing?
We'd done a few tests at like 20 psi just to see if it like rolls with a person on it.
Yeah.
But it felt more like that felt like a push. Do you know what I mean? It felt just like a kind of like someone was pushing you quite fast.
Yeah.
The first time we rode it, I rode it on about, I think it was 60 psi or 60 or 70.
Yeah.
And it was pretty violent. Yeah. Yeah. And I wasn't expecting it. But there was some other, because there were other considerations, like originally we had the tube. It was going to ride completely in line with like the center of like force, the center of mass. So it wasn't gonna push sort of off center. It was
right. That's what we were thinking about. Where do you, if you're gonna build a pusher thing, where do you put that anchor point? Where do you push? And so center of mass that's the intuitive answer. That's not the answer.
Yeah. Well, the problem is that the center of mass for my thing was directly on my spine, and there was going to be, you know, about this much wood between a 3 meter long spear and my spine, and I was like, if this thing goes wrong, like,
yeah.
And so I decided, you know, okay, it will be a bit less efficient, but what I'll do is I will mount the cylinder underneath and in front of the person, so it's pushing always in front, so that if that thing snaps off, the catch car snaps off, that piston's just going straight out the front. It's not going anywhere near me.
Smart.
And the other thing was,
I'm sure your folks were happy about that. I think they probably thought that was a good feature.
Yeah, so like we'd kind of done like a risk assessment of like what could go wrong. And so like, oh, well, if the stress is too high and the pressure goes too high and you get a failure in the PVC, what will happen? Well, we got a solid floor on the cart. Yeah. And the other thing is that because it's a piston, the pressure is always behind you.
Yeah.
And so it's never actually, you're never in the danger zone.
Yeah.
You'll notice actually in the video, you can see the effect of the off-centerness because the back wheels dip down when it fires.
Yeah. So you get deflection of the PVC track a little bit on those wheels that you use. So it does cost you something.
It costs a bit, but we found that we could just put an extra 5 psi in the tank.
Yeah, it's like, okay, if you can afford it, that's fine if it costs you.
Yeah, so it's there was always, because like air pressure seems to win out over everything. So like we had problems with friction with the piston, and we were like, oh, is that going to cost some points? It's like, nope. 1,200 pounds of force does not care about a bit of friction.
Yeah, it's like also good. Tell me about the piston, or tell me about. So I looked really closely at your video, and I looked at the plywood. You first, what I noticed is that you used like beautiful plywood. It wasn't just like, you know, cheap ass. To me, from where I was sitting, it didn't look like cheap plywood. And then how did you cut the stuff? Is that laser cut? Because it looks beautifully done. I mean, you know,
in which on the car or on the piston?
Well, I was looking at, there's one piece of the track. There's one piece where a piece of plywood goes across the track, and then you've made this form thing. That thing. Tell me about how you made that.
That's so it was a square.
Okay.
And then we just used a hole saw and just
a 4-inch hole saw.
Yeah, and then you cut this shape out because we wanted a bit of spring to it.
Sure.
And then just sliced it down, and because the blade of the saw has a thickness, it takes out some material so that you can clamp it down.
So you get a little compression there.
Yeah, so originally we were going to be putting rubber around the, I'll bring out the pipe in a sec. We're going to put rubber around it. So it would be like PVC, rubber, wood. But then we clamped this, and we had 4 of these, and we didn't need the rubber. Wood on PVC, 1,200 pounds, did nothing to it.
Yeah, it's really, really grabby.
Yeah.
So, okay, yeah, because one of the things I'm currently having, and then like you'll like see it in today's video. I'm like talking about the pneumatic thing and all of this stuff, and then like over my shoulder is John, and he's my mate who we work on this stuff together, and he's a commercial electrician, right? And so we've been talking about 10 horsepower motor with a 20 horsepower variable frequency drive and a cable thing, and so sort of mimicking the Intamin launch thing without the nitrogen. We really do want to do a cable launch. I got a couple of worries about it because I know that Intamin has had some failures of their cable system, right? I mean, I know that like the actual pros, yes, there are. And that's like a video. My goal in life is to never make that video. So there's that, but I do love that with an electrically powered thing, with an overpowered thing, right? We did all the math, and you don't ever need more than 5 horsepower even to launch like a 450-pound payload. So if you had a 10 horsepower motor, you can absolutely control the speed of the thing, right? You can, and all of that. But so anyway, but then I'm like, and then Paul Gregg, and I saw your video and everybody, I'm like, God, Pneumatic, man, you could just like, it's so easy and so inexpensive and way safer, I think. And I'm talking about that on the video, and then over my shoulder, I see like John over my shoulder, and I'm talking about the Pneumatic thing, and you can just, he's very, very kind and doesn't jump in. He's like a really gentle person, but you can just see ever so slightly, he's like, yeah. I'm like, John the electrician really wants to build the electric cable launch.
I think because it would be wicked, it would be amazing. A cable launch. So I went through and sort of, I came from the position of like, I want to do this. I don't have much money. What feasible ways are there for me to do this? And so I went through all of them, like gravity launch. I went through like doing a cable launch, like with a motor. And then also I even looked at how much it would cost to build like a LSM limb type deal. And do that. But because the thing is, right, is that 10 horsepower motor will kick out 10 horsepower all day long, right? Which means that, it's going to be, it's going to cost for that.
It's expensive.
Whereas what I've done is built like a giant mechanical capacitor where I have my silly little half or third horsepower air compressor, and I can leave that running for 2 or 3 minutes. And it's pumping all that energy into that tank to release it in half a second. And so I can get away with much lower powers, over a period of time. Because I only need it for half a second. I don't need for it to be running constantly, like, And so air felt like, one, I have some experience in pneumatics. I built sort of this kind of stuff before, which is how I knew about the piston valves. I built my own piston valves. And so I knew that there was some serious power behind it. And then it also was the cheapest option. It was the cheapest, most reliable sort of option where I kind of knew that it would work to an extent. I didn't know how well it would work, but I knew that it would do something. And so with like a cable launch, sort of the motors were sort of way out kind of price range for me.
It's borderline ridiculous. Well, it's not borderline ridiculous. It is ridiculous.
And then you need all of the stuff like around it. So you need like you were talking about the controllers and this, and you've got to do all the whole like variable drivers and all that. And so it was it was, but the decision took me about a year for like all the parts.
Really?
Yeah, I mean, this project, it's been in my head for about 2 or 3 years, where I've been wanting to do it. I mean, wanting to build like a roller coaster. And, when I started my channel about a year ago, I thought, okay, the big one that I want to do eventually is a roller coaster.
Right.
And I built up a small library of videos, like got practice in, talking to a camera, which is really scary doing that. I didn't have an experience doing that before. but just turning on a camera and like filming it is weird.
Yeah, it's
But,
it's like kooky. It's,
yeah, they tried to explain to people. Now, like, you do what?
yeah.
So then I built it, tested it, and it worked better than I thought it would. And then shot the video. And I tried to keep it as sort of, I didn't want to like do stuff just for video. So all I did in it was just reset it a bunch of times.
Yeah.
And then just shot people off. Yeah.
In your reservoir, in your tank, what is the PSI that you put in the tank?
So you do it based on the weight of the person. So
okay.
So my weight limit was a hard 90 kilos. So what, 200 pounds for a person.
Okay. Now you don't weigh anywhere. You're nowhere close to 200 pounds. You're like a skinny little. No. One of your friends though, that went on the thing after you,
it looks slower.
Yeah. So tell me about that. So that
was the limit where we under pressured that launch. That launch was pressured for me, and that's how we found out that it makes a big difference. So for someone like me, I can get 4.5 Gs off about 60, 65 psi, 70 psi, something like that.
Okay.
But with him, he would need closer to 90, 100 psi.
Okay. And what's the capacity? What's the max psi of your tank?
100. It's the PVC's it's scheduled 40, I think, or it might be a bit more than that. So it's rated to about 150 psi or a bit more than that.
Yeah. And then if you go up to schedule 80, I think it almost increases by an order of magnitude.
It goes a whole lot more. You're getting into the kind of 200-300s, I think, or more. Yeah. So that was. So, I mean, I would have built it out of steel if I could, and I would have made it a 5-meter launch if I could, because I think a 5-meter one gives you a lot of time to build up speed. You know.
Yeah. So you'd need a 5-meter piston.
Yeah. So that was the other thing. So hang on, So I've got it here. It's pretty big. Let's see if I can get it in shot. It's like this.
Damn.
So this is the end of it. Oh.
Yeah, that thing is famous now. All right.
So that you can see, this is a plug of wood where I cut it on the hole saw, but it's about this many.
So like 3 or 4 layers.
It goes in, and then I've screwed in quite far, because I did not want this thing coming out.
Yeah.
And then the other thing is that you're going to have the piston coming up, so there's going to be air pressure behind it.
Yeah.
And then it comes to about here, and these holes which are here and on the other side, they vent out.
Love those holes. I love at that part of your video where because there's condensation in there and you get that. It's like awesome, dude. It's absolutely great.
But then we left a section here with no holes. And the idea behind that is that it adds an air cushion so that as the piston goes past here, it doesn't smack into this piece.
Look at you thinking of stuff.
Kind of rebounds a bit. It gives it a bit of cushion. And so what it means is that you don't really get any noise from this. It's really smooth. And it detaches really smoothly as well.
Yeah.
So,
and that was one of the questions I had about your if you had like a really long one, if you had a 5-meter launch, could you also use that as an air brake for rollback, right? Would there be a way to manage that? And so if it does roll back and bang into the piston, it would slow it down.
Yeah. So we had some rollbacks.
Nice.
So the way ours was, it was straight. It did a hill and then it went up, and then it would most of the time it would settle sort of like this.
Yeah.
But if you got right up to the top and you bang the end, especially, it would go right back over the hill and go right to the start.
That's awesome.
Yeah. And what would happen is that this piece here would, at the end, which was sticking out, it would catch the catch car and it would compress the piston again.
Nice.
And it would bring it back. Yeah.
And how do you did you there would have to be some sort of like droop in the piston.
Yeah. Yeah.
But it wouldn't drop enough to where you could still, and you've only got 3 meters there of.
It wouldn't seat in the hole. It would be a bit lower. It wasn't like it wasn't a perfect match, but we had a bit extra at the bottom.
A bit extra,
and that was enough so that it caught it. Yeah.
Okay, dig it. And the piston itself is steel, not plastic.
This is a solid steel tube.
Okay, dig it.
And it weighs a lot, you know.
Yeah.
So
I am familiar.
Yeah. So I was worried actually. I thought, you know, whole mass acceleration, you know, type deal. I thought it's going to add a lot of kinetic energy, and I thought this thing's going to be like a battering ram. It's going to blow out the PVC.
Right.
So I thought I'll get one shot of this, and I'll fire it, and this whole front end would just.
But it worked out.
Didn't even care. It didn't care at all. It just it fired beautifully, and the other thing was, which I didn't expect, is you could dry fire this thing. You could fire this thing with no one on it, and the piston would do exactly the same thing. It would move at the same speed, and it would stop, and it would cushion itself just the same.
Really, it doesn't just get like now. All right,
Which
so now I'm like,
makes me think that it's limited by this. It's limited by the speed that this thing can dump air at the end.
okay, yeah, because it would seem to me if you could just, you know, if you had like a 4-inch piston valve instead of a 1/2-inch piston valve, you could just like blow the thing apart, right? But
yeah, so see, I don't. Yeah, see, I don't know. I mean, it would be a bit more scary. I think you'd definitely have a much harsher launch because this thing, because it wasn't such a big porting, it allowed sort of the piston to build up pressure and then to sort of vent it, sort of a bit more gently, just a bit.
Okay, so here's the space, right? You've seen it, right? This is kind of like where we're gonna start, and then from here to the end of the track there, that's about almost.
How long have you got? Yeah,
like 80 feet. So if you go all the way down here, we've got like 80 feet, and then when I get down to this spot, this is where we want to go up. So we want to like do our top hat.
Oh, watch out, you cut out.
But again, like, oh, hang on a second here.
Yeah, we're back.
We're back? Okay. I got too far away from my, I'm going to have to install another access point out at the other end of the.
Yeah.
We can put 200 amps of electrical power anywhere on the property, and 200 amps. Yeah. John's an electrician, man. He's a commercial. John's real job. He builds skyscrapers in San Francisco. And
Will, you're crazy.
Yeah, so we're not going to use it for the coaster, but I mean, it's available, right? It's like, you know,
when you need it.
And we can also use 3-phase. We can also like convert to 3-phase power. And so we've got like all sorts of like ridiculous electrical choices that we could make. But
wow. Yeah.
But like, so we're trying to think of like the best ways to do the thing. I want it to be all steel this time because I've never built one that was like steel from the ground up. And the more I think about it, since it's a launch thing, and I'm in love with my little Tesla car that I got. I think we might even theme it as a Tesla sort of a, right? We might want to design the car as like a little mini Tesla car. There's a
Are you gonna have more than one rider?
More than one rider in the car? I haven't thought of it. It's going to be crazy strong, and it's going to be wide, so 24-inch gauge track instead of. I think yours looked like about 15.
It was 50. It was 50 centimeters or 60. Yeah, 50 centimeters. So that's about divide that by 2.5.
So terrible, yeah. Right. Hey Siri, what's 50 centimeters in inches?
50 centimeters is 19.69 inches.
19.69 inches. Okay, so that's wider than it's narrower than it looks. And so we've got 24 inches.
Yeah, you got some extra room there.
So the last one we did was 18, so a little narrower than the track that you built. So we might could. I don't think we could put people side by side, but you might.
I was thinking one behind the other is what I was thinking. Yeah. Yeah.
So ridiculous.
And if you're doing steel pipe, then the pressure rating on that is sort of whatever. It's
thousands of pounds.
Yeah. You don't even need to bother. And so you could put behind it sort of whatever pressure you want. But if you're doing electrical launch, you're gonna have to double the power.
Yeah, and it's just like it's so freaking expensive. So anyway, John and I gotta have. I really want to do the electric thing, but like I could just like go off to the hardware store and come back this afternoon and like get started on the launch on the pneumatic stuff. So I really like the pneumatic thing, and John really likes the electric thing. And I love John so much that I want him to have everything he wants, but. But I mean, it'll be like, I think it'll probably be 10 times as expensive to do an electric launch than it would to do pneumatic. But okay. So what was the
I was going to say, you got with the electric launch, like, are you going to be rolling up a drum, sort of cable on a drum?
Thinking about that.
But then what? So I was thinking about it, and I was sort of I did some kind of quick sketches of what it would look like, and the problem that I have was what happens when it gets to the end. So you're going to be stopping that motor immediately.
Well, you need a braking system. You need to a variable frequency drive. What you do is you tell it, from this point to this point, either in time or in space, accelerate to this speed. And so with a variable frequency drive, you're not just like turning on a motor.
Yeah.
You're spooling it up and spooling it down, and so you can manage all of that with using John. You can manage all of that.
Yeah.
And but again, you've basically now got two roller coasters, right? You've got your catch car, which is a whole system unto itself.
And you got to build the whole cable management system. You got to do the whole.
You got to build cable management system. You've got to build that. All I want to know is what happens if the cable snaps, right? Because like I'm trained as an aeronautical engineer. I'm a pilot. I've got a whole lot. I've had a whole lot of experience with a whole lot of things where 80% of the business is what if something goes wrong, right? So like 80% of pilot training is what do you do if the engine fails? What do you do if there's a fire? What do you do if something goes wrong? And so I'm all about, right? I don't need to practice a whole lot for everything being perfect. That tends to take care of itself. What if a cable snaps? How do you manage that?
Yeah.
And I know, and again, I know Intamin thought of that stuff too, and they didn't have a good answer once upon a time.
Oh, really? Yeah.
Well, one of the accelerator at Knott's,
there's that video.
There was a cable snapped.
Yeah.
I'm pretty sure that kid is still in a wheelchair. So and
it's brutal.
So that's a huge concern.
Yeah, I had these kind of like visions of like these stories of when they're launching planes off aircraft carriers. Yeah. And the cables for them snap. Yeah. And that thing ain't stopping for anyone. If that cable snaps, it's going places. Yeah. And there's a whole lot of energy behind it.
Yeah, enough to launch an F-35 into the sky. So there's massive amounts of energy, and so that's the big concern. And when I think about the pneumatic thing, there's so maybe 100 psi. If you're putting all of that stuff in steel pipes, you want to splurge and get steel pipes. It's more expensive than plastic, but not crazy. It's a really, really manageable thing from a safety perspective. So so anyway, we'll see. John is like, he's got pen to paper. He's working on the design of the.
But if you do pneumatic, go with a longer launch than I am, which is a 3 meter, about 12 feet. Bit more than 12 feet. Yeah.
Yep. Well, the general idea is we want the thing up to speed in 20 feet or less. So that's
20 feet
That's
20
what.
feet.
Because then, like 20 feet, you go. Then you've still got like 40 feet of ride of heading towards, and we want to go 90 degrees. We want to go straight up. right? We want to go like full top hat. So 20 feet of launch, and then you're at speed heading towards, the wall of track, and then you go straight up, turn over the top and down. And so that's kind of the vision of the thing, is like there's a 20-foot, 4+G launch.
Yeah.
40 feet of, oh my God, I wish I hadn't have done this, and then straight up and over, and then figuring out how to slow the thing down. That's a whole nother.
Well, I wanted to do magnet. I wanted to do copper plates, and magnets and the whole deal, and have it so that the noise it makes.
Oh my gosh, I want that so bad. I was at the gym the other day, and there's these spin bikes, and there are these big aluminum discs on the back, and so they're actually really light. Spin bikes used to be these big steel things, but they've got these aluminum discs for the wheel, and then it looks like two, maybe 3 centimeter diameter by a 0.5 centimeter neodymium. I guess they're neodymium discs, these little magnets, and these little magnets act like a caliper, and they go in, and that's how they add the friction to slow down the spinning bike, because you turn up and down.
That's clever. That's really clever.
It's really, really cool. So my big question about, and we're thinking about magnets too. My big question about it is like, how big of a magnet do you need? Did you do any of the calcs on that?
I did some experiments. The answer is you need quite a lot, and they need to be quite big. So you would have the magnets. How did I do it? I had the magnets on the car, and then I had aluminium plates on the track.
Yep.
You can't do it in the middle, because that's where your whole launch system is. So you have to do it off center. Yeah. It's another thing, but that's okay. And I think I needed a 6-foot run to slow me down.
Okay. Yeah. Well, and then how long the run is, that's probably not the expensive part, because that's just the aluminum plates.
But then I needed magnets kind of this, about that, because the kinetic energy of a kind of 100 kilos moving at sort of 15 miles an hour, it's reasonable. Yeah. But the other thing, if you do go piston, the thing is that however long you launch, you're going to need that space behind it as well. Yeah. Because you got the whole piston behind it, so you'd have to have it'd be straight, then the launch, then it would go up, twist down, and then round the back. And if you're planning on coming up, doing the whole circuit and then coming back around, you would need a spring-loaded catch car, so that after it fires, it flips up, and then it can ride over this without smacking.
Yeah, we were thinking about just one on a just exactly that, spring-loaded, so that it'll get up out of the way, and that way, the magnets wherever those things are, can
and then when you ride, because you're gonna have to ride over the piston to reset it.
Yep.
And so, but as long as it'll be fine.
What could possibly go wrong? Oh, maybe you have maybe at the station, you get on the thing, and then all of your pneumatics are underneath the station, and then there's just this little drop, just like a little 8-inch drop. Right?
That's it. That's exactly what you should do.
That's the way to do it, right?
That's smart. Yeah. That's
That'd
how
be
you do
cool.
it. So the whole, that is perfect. Because then the whole launch section would be underneath the track, and you could turn the corner whenever you want.
Yeah. Then the piston pops out wherever the piston pops out, and then so then that doesn't get in the way anymore. Yeah. And it would look cool, and
if you want to be really insane, you would have it so that as the thing drops down, it automatically fires you.
That'd be so cool. Because Arduino.
Yeah. Just having a light sensor. You roll out the station and just pow.
Nice. Yeah. All right. And then maybe we can incorporate some electronics into the thing, which John really, 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 really loves.
Oh, so one last thing. Make sure your seat has padding. Because I didn't have padding. I was launching on bare wood to start with, and I think it straightened my spine.
Yeah.
It was so powerful.
Cool.
And I had a kind of a flat board with a kind of headrest. And The next thing I did was put some padding on it because everything I learned was American. You know, but the type of plumbing you guys have is much more extensive. It's all laid out. It's all clear. Everything's just better than what we have. So you have to make do. Yeah, which is why I kind of learned about this kind of stuff, because we kind of have a lot more copper over here, and these are designed for like copper sort of small based actuators and the whole lot.
Yeah, those are brilliant. Yeah. All right. Will, I'm such a fan, man. I loved your video. It kills me a little bit that this coaster doesn't exist. I feel like I should maybe talk to your folks.
Hey, don't worry. I think there's a chance it might go up again.
All right.
It might go up again.
Okay, you've got all the bits and pieces, and it's also encouraging that this is a modular device, right? Because that you could like,
it splits up into 5 meter sections, and so you can just take it down. It was 4.5 5 meter sections.
Yeah.
Stake it into the ground, do it up. We put the whole thing up in a day and a bit.
Nice. Okay. Well, this one is going to be. This one is like going to be built all on level ground, and so what I hope to do is like build it over the next couple of months, and then we want it to be modular because I want to take it to the San Francisco, the Bay Area Maker Faire, and I want to put it up. I put one up at a Maker Faire once upon a time.
You did that. I saw a video where you built a roller coaster and took it to.
Yeah.
You took it to that place, didn't you?
Yeah, we built a roller coaster, and then we took that roller coaster down, and then we took it back, and we tried to put it back together at the Maker Faire, and we ended up building a completely different roller coaster at the Maker Faire in 30 hours.
Wow.
It was like, it was a testament to optimism.
That's impressive. That's really impressive. Because this thing took me about 3 or 4 months.
There's almost no video of that event because we were so under the gun and exhausted and under. It was a really, really optimistic idea when we first started it, and it turned into a real adventure. But anyway, this one I think would be really cool, and we could build it to where people could ride the thing, and so that would be freaking awesome. All right, Will from London, thank you, my brother. It's been like so much fun. It's so much fun hanging out with you. I'm a big fan.
You too.
As I've said a million times. Yeah.
Yeah,
Okay,
I'm
cool.
a very big fan of yours. So thank you for this. This has been amazing. Yeah.
All right.
Great
So we'll cut out some of the super secret bits of this video, but I'm gonna like put the whole. If it's okay with you, I'm gonna put the whole thing up, and we'll just like share this as like part 3 of the backyard launch coaster adventure.
Perfect.
Thank you for helping us bring physics, family, and fun to kids everywhere. I am Will Pemble.
And I'm Will from London.
Will from London, and we'll see you soon.
See ya.
All right, dude.